It's almost like a test day when I'm in the simulator, and it's really valuable for me and for the team approaching the weekend.
F1 simulation is really it's a virtual representation of our race car. What we're trying to do is we're building models in a computer environment, and that way we're trying to represent all the different aspects of the car. And really we bring these models together to create a total simulation. We're running the car in a virtual environment without ever having to run it physically on track. And we're using all of our tools to learn about the car, to set it up as well as we can before an event, but fundamentally trying to maximize the points and the performance that the team can have at a race weekend.
At Mercedes, we use a range of different simulation tools which can help us from designing componentry all the way up to full car simulations of the entire lap of the circuit. Running simulations allows us to try many different ideas virtually before we commit to making any parts physically, which can save us in terms of time and expense as well as wastage of material. With the very limited testing time in Formula 1, it's increasingly important to start the race weekend with a good setup. Simulation results can also be cleaner than testing components like the race weekend due to many factors such as traffic from other cars, weather changing, the grip changing during the race weekend, and lots of small factors that mean that even the best racing drivers in the world would have difficulty picking out those small differences. Using simulation tools, we can see many small differences by sweeping many different components, which allow us to define the best overall compromise for the vehicle for the race weekend.
In strategy, we have two main simulation tools. And unlike the rest of the race team, we don't focus on our car and how to make our car quicker. We instead focus on the whole race, and we try and simulate not just what will happen to our car, but how the race is going to play out and how we can have an effect on that. Our two tools, one of them is called the Race Planner, and that is a tool that allows us to visualize how a race might look. And the real power of that simulation is that we can share it with other people. So in the morning, that might be showing a simulation to the drivers and talking to them about what they might have to do at certain times. And it might be live in the race. We're sharing plans with the pit wall and trying to describe to them our ideas to help the team come to a conclusion on exactly what we'll do. So that's simulation 1. And then simulation 2 is based on a principle that's aptly called the Monte Carlo method. And that is a simulation that runs the entire race and has many, many small components, most of which have a random element. So that might be what strategy every car does. It might be whether an overtake happens or doesn't happen. And it means that every single one of those simulations has a completely different outcome with the same inputs. And what we do is we run millions and millions of these simulations on a computer cluster, and we use that to investigate what might happen in the race. So we get a sort of a distribution of probability over what could happen, and we can then look at what we can do to influence those probabilities and what strategy, what stop laps, etc. might maximize our chance of getting the most points. The benefits for us as a strategy group are huge. It's impossible for any human to really visualize all the ways in which a race can play out, let alone calculate all the different probabilities that are involved. So without that, we really can't understand all the different nuances and all the different things that can come into play during the race in order to make the best decisions while it's going on. That being said, the simulations very much are a tool and a guide, and at the end of the day, the decision on whether to stop or not to stop, what tyre to fit, is a human one, and it is driven by the wealth of experience we have within our strategy team.
An F1 simulator is often called a DIL simulator. So the DIL stands for driver in the loop. And the key bit that the simulator is different to other simulation tools is that we need a driver in order to drive it. All the models, all the work we do is so that the driver can interact with the virtual car, and that way they can drive it around the track. So that way they can learn about the circuit, they can find the best compromise for themselves in terms of the setup. We have lots of virtual elements to a simulator. You have the screens where you project the track, you have audio where you simulate the sound, but also we have real aspects. We have a steering wheel, we have pedals. All of these things are trying to make the experience of the simulator as real as possible, whilst also working with a virtual car and a virtual model. An F1 simulator, there's a wide variety of uses. Firstly, we're trying to help the team prepare for the race events. We sometimes have the race drivers who may use it to come and see which setup compromises they want before an event. for new circuits. They may come in and learn the racing lines, the braking points, etc. And really what we're trying to do with the sim is we can isolate parameters within the simulator environment. We can fix sort of weather conditions, we can fix the setup, and that way we can find out which aspects of the car are important to our performance.
From driver's perspective, the Formula 1 simulators, they are very important nowadays. Of course, the technology has improved a lot since I joined Formula 1 as a test driver 11 years ago. They're definitely getting more and more realistic, and with so limited practice nowadays on track, with limited pre-season testing and in-season testing, that's the main practice we actually get in terms of driving, learning new tracks, trying different setups.
This year we've had a restriction in our practice times, the practice times now being 1 hour for every session, and it's become really important that we hit the ground running when we arrive at the circuit. The practice is so limited that we have very little time to make big changes, and that's where the simulators come in. It's really helped to try and be best prepared for an event, to really have the best sort of car we can before coming to the circuit. But also what we're doing is we're using the sim during an event. We're helping to advise on setup decisions between a Friday and a Saturday, and that's where the importance seems to be growing this year and probably in the future as well. We run the sim very often. We're using it every week, approximately 4 days a week. And within each test day, we'll often run through 120, 130 laps. So we're covering often more than 2 race distances within 1 day. In the simulator, we have the opportunity to log up to about 4,000 channels, covering all aspects of the car. We've got the power unit, the aerodynamics, the suspension, and really we're looking at every single detail that we can within the virtual environment. At the end of each week, we have about 100 gig of data. And although 100 gig doesn't sound like a lot, but we only have a very small team, so 100 gig to go through and analyze is a big task overall.
Normally, when I'm in the simulator before the race weekend, I want to get my eye in for the track, just to familiarize myself of the braking points, the different lines and different line options through different corners. And also we do quite a bit of setup work. So we go through aero setups, different mechanical setups, all these kind of things. And we go through short and long runs, and it's almost like a test day when I'm in the simulator, and it's really valuable for me and for the team approaching the weekend. I like it because it helps me to perform better in the weekend, and it helps the team perform better in the weekend. The main knowledge and information I get from simulators is learning a new circuit. The team can go there beforehand, scan the track, and the track can be exactly the replica of the real track. And get to know the layout, get to know the bumps of the track, the cambers, off cambers, try different driving lines. I can also learn a lot of knowledge about the setup direction to approach the race weekend beforehand.
For some simulation ideas, we'll always need the feedback of the driver. Producing these sorts of components can be very, very time consuming and expensive. By allowing the driver to test these in the driver in the loop simulator, we can get their feedback very early on about whether an idea is going to be suitable for how they drive, or is going to be too much of a problem for them. This sort of driver feedback is essential for us in order to develop with the most efficient way, so we get the most performance for the amount of expense and effort we put into the simulation work.
The simulator is a very accurate representation of the car. It's what we believe is the closest representation to driving an F1 car. As the sport becomes more restrictive in terms of track testing, the opportunities to use the car on track are becoming limited. And as we're looking to control costs, simulation tools are really a very economic way of developing and improving the car without ever having to drive the car on track.
So when we simulate things for a race weekend, we tend to limit ourselves to the components that are in the box, as you could say. So only components that are there for the race. When we're developing the future car, we can be much more adventurous in terms of what we simulate. By changing simple numbers in the simulation, we can change things like the vehicle weight, the total vehicle size, or even things as large as the power unit. By producing these types of very different vehicles, we can do lots of simulations to see if that development direction is actually a good thing to go for, or wouldn't be worth the expense. By exploring all these different wild ideas, we're able to eventually end up with componentry such as the DAS system from last year.
But as the reliance on simulation tools grows, it becomes even more important that we use the simulations in the correct way, so that we're always sure that they're accurate, they're representing the physical car. And that element of validating them, that's always going to require a human. So although the simulation tools are becoming so important, there'll always be that human aspect which you can't get away from.